Welcome, this is 8.5, Properties of Logarithms. In this section we're going to continue what we've been learning with logarithms, only we're going to learn some specific properties that let us change a logarithmic statement, and we use this to simplify. I'll say more later, but there's a few properties that we're going to learn to start off with. The first one is called the product property. The product property. And I want to remind you of the product property we had when we were doing exponents. So remember from your past in chapter 7 when I had something like x to the m times x to the n. In chapter 7, remember, we added the exponents. Now I've been saying this a lot lately, but logarithms are the inverses of exponents. So what happens with a log is very similar to what happens with the exponent because they are related. They're inverses of each other. So here, if I had a multiply between my things, I actually add the exponents. When I have a log, here's what this looks like. Let's say I have log base a of u times v. That is the same thing as doing log base a of u plus log base a of v. So I split them up and they each got their own log. The next one you're going to learn about is called the quotient property. This one matches with what we learned with something like x to the m divided by x to the n. Remember, we subtracted the exponents. So here's what our quotient property says. Let's say I have a fraction, log base a of u divided by v. That is the same thing as doing log base a of u subtract log base a of v. And last but not least, we have something that I call the power property, but it's not really an official name. Here's what the power property says. Let's say I have log base a of u to the nth power. So this thing here has an exponent. I can take the exponent and put it in front and say n times log base a of u, and it is equivalent. So those are the three properties that we're going to use. We're going to use these to simplify expressions, and we're going to use these to do something called expanding and condensing some logarithms. So we're not really solving anything today, we're just changing the format and trying to find a numerical answer in some situations. Let's look at example 1. It says use the properties of logarithms to approximate each. And we know that log base 5 of 3 is approximately 0.683, and log base 5 of 7 is approximately 1.209. Alright, you're going to be given some statement. In this part right here, they have used a 3 and a 7 in some way, and then we're going to think about the properties of logs. So in this situation, what they've done is they've given us a fraction, so I can first split this up into log base 5 of 3 minus log base 5 of 7 using the quotient property we learned. So just notice that the base was 5 instead of a, and then 3 and 7 instead of u and v. Alright, now the reason I wanted to split it up this way is because I know these, they were given to us, and this is the way I can do this without even using a calculator. And I'm just using the information they gave me up there. So I've got 0.683 subtract 1.209, so my answer for that statement is approximately negative 0.526. Part B. Now I need to think of the number 21. How is the number 21 related to 3 and 7 is what I'm asking myself. And hopefully you can see that the number 21 is related in that it is 3 times 7. So when I rewrite it as log base 5 of 3 times 7, now it matches with my product property. So now it matches with my property that I can split this up into log base 5 of 3 plus log base 5 of 7. And this is equal to this. If we're going to learn at the end of this lesson actually now how to put these into your calculator. But if I put the first thing into my calculator and the second thing, I'd get the same answer. Alright, let's keep going. Now I'm going to put what I know the decimal approximation to be, so 0.683 plus 1.209. And so this is approximately 1.2773. Last but not least, part C. So I got log base 5 of 49. Again, think of how that is related to 3 and 7. And in this situation, actually, there's no 3 involved. It's just log base 5 of 7 times 7. So that's going to happen sometimes. So this one ends up being log base 5 of 7 plus log base 5 of 7. And log base 5 of 7 is 1.209 approximately from what we got there. So here's what I've got. And my answer then, add them together, is approximately 2.418. All right, your turn. So at this time I want you to pause the video and try D, E, and F. And when you unpause, I'll have the answers showing, and then we can go over these in class more if you need to. All right, here are the answers for D, E, and F. How'd you do? Hopefully pretty well. Let's move on to example 2. Now we're going to use some of our properties in a little bit of a different way, but we're going to still be using our properties to evaluate without a calculator. So here's what I've got. Part A, I've got log base 3 of 9 squared. All right, here's what I want you to think about. Log base 3 of 9 squared. Well, I just taught you that whenever I have an exponent, I can move that to the front, and that's not always going to be our first step that we want to take. It does work in this situation, and the reason it works in this situation is because in my mind I was kind of thinking, hey, I know how to find log base 3 of 9 without a calculator. Now review from our previous sections, log base 3 of 9, to figure out what this answer is, we're trying to figure out what power of 3 gives us 9, and whatever goes in this box is what this whole thing is equivalent to. So this is an easy one because I hope you can see 3 squared is 9. So this entire log statement is just equal to 2, and I'm just going to carry down the 2 from before, so now 2 times 2 is 4. Alright, let's do the next one. In this situation, I could multiply them together, but I see that they're separated, so in my mind I'm thinking, well, they probably did that because they want me to use one of my log properties. So I look back to my properties, I see it looks the most like the product property, so I'm going to split this up into log base 5 of 5 plus log base 5 of 125. Notice that whenever I'm splitting these, every single time, each piece gets its own log base 5 or log base whatever, so each piece is going to get its own. And now we're going to try to do each of these separately without a calculator. So again, every single time I'm trying to figure out what power of the base gives me the big number. So first I have 5 box equals 5, so that's just going to be equal to 1, or you may have remembered as well that if I have the base and this number the same, it's always equal to 1. But okay, anyways, here for this one I'm trying to figure out what power of 5 gives us 125. Do a little guess and check if needed. It ends up being 3. So my final answer for B is also 4. Alright, look at part C. So in this situation, again, I'm kind of thinking that I would like to take this 5 and carry it down. And in this situation, it actually will work if we distribute the 5 as well, but we'll try it this way. Alright, here's what I've got to start off with. I am seeing that I have a fraction right here, so in my mind I'm thinking the quotient property. And now watch this, that 5 was in front of this entire log statement, so when I split the log statement up, the 5 needs to go with both of them. So to make that happen, I put this whole thing in parentheses. So then 5 will be multiplied by what the whole answer that's in this parentheses then. Alright, so now again I've got some log statements to solve. So this one I'm thinking, okay, what power of 4 gives me 1? And this one I'm thinking, what power of 4 gives me 4? Alright, remember, this is both of these are special situations this time actually. And whenever I've got 1 for my answer, the only way I can make that happen is if it's 0. So the answer to that is just 0. And then whenever I have these two things the same, well, the only way I can get a 4 back again is if it's 1. Still have the 5 there. Alright, but 0 minus 1 is negative 1, so 5 times negative 1. 5 times negative 1. There I go. I threw this last one in here because I wanted to show you that, remember, a ln log is the same thing as a normal log, so same rules apply. So if I look at this ln log, I first see that it has a fraction bar, so same rules apply. The quotient property applies. I got ln of 3 subtract ln of e cubed. Next, this part, as of right now, we can't actually simplify that unless we do use our calculator, so I'll just leave it as ln of 3. And then over here I put in the base so that you could see what's happening here. Remember, if you have the base and this number the same, it's just equal to the exponent. Well, now we know this property as well, where I bring the exponent into the front. This part is equal to 1. So really what I've got is the natural log of 3 subtract 3. Make sure that if you have any questions on this section, you write them down or make note of it, because I'm guessing some of these we're going to want to work through the next day in class. Let's move on to expanding though. So one of our goals here with these properties is to make our log statements we're usually using the log properties to condense them because that would be what we'd want to do in a problem situation, but we're going to also practice going the other way, which is expanding logs. Here's what I mean. When I'm expanding, my goal is to make it so that every single piece that I have in my log statement has its own log, and every number and variable counts as its own piece, except the base. The base just goes with the log every time, so that we don't worry about. Alright, so if you want to, when I'm trying to expand, I can do this one step at a time, or I could do it all at once. Let me show you a little bit of both. So first of all, I've got 7x cubed on top. It's like 7 times x cubed. So in my mind immediately I'm thinking, okay, log base 2 of 7 plus log base 2 of x cubed using my quotient property. And then all of those are divided by y, so that is going to end up being log base 2 subtract log base 2 of y. Now notice, this is what I meant when I said each one of these pieces to start off with gets its own log, and the 2 just sticks with the log, so don't worry about the base. And here's a shortcut. When I'm expanding, anything on top is positive down here. Anything on bottom is going to be negative, and I'll say more about that later, but the reason is because of the quotient property. In the property I only showed you one thing on bottom, but if I had more things on bottom, all of them would be negative. Alright, last but not least, to fully have something expanded, I don't want an exponent, so I'm going to move that exponent to the front of the log for this middle statement. All the other ones stay the same, and then I'm done. So you might want to make a note to yourself. This is very unofficial, but every piece gets its own log. Also, we don't want any exponents when I'm expanding. And I want to point out that we haven't actually solved for anything. All we've done is kind of move stuff around. So that's sometimes what throws students off, is that it may seem like we haven't really done anything because all we're doing is changing what it looks like. Let's do part B next. Alright, notice how this time, when I have 2x to the 6, it really means 2 times x to the 6th, right? So the reason that's significant is because that means that I can use my product property. This means I have log of 2 plus log of x to the 6th. And notice that these ones don't have a base. So again, whatever the starting base is, you just keep it the same all the way through. This one doesn't have a base, so remember that means it's a common logarithm, so it'd be really base 10. Last but not least in this problem though, I need to move that exponent to the front. So I got 6 times log of the x and then log of 2, and that is it for my final answer. That's it for this video, so tune into the next one for the rest of the. Welcome to 8.5 Part 2. We're going to continue with the properties of logarithms, expanding some situations here. Just to review, remember, I want every single different piece in the part not with the log, so everything I highlighted here, we want its own log, and we don't want any exponents when we're done. And remember back to example A, I had given you this shortcut that if I've got a fraction, anything on top is going to be positive, and anything on bottom is going to be negative. So if I look at this, when I split this up, log base 7 of y is positive because that's on top, and then both of these are on bottom, so both the 3 and the x squared both get a negative. An alternative way of thinking about it really quick, let me show you. You could think of it like this. But then when I split up the log statement, I would get the same thing anyways. So the shortcut just is, if you have two pieces on bottom, both of them are negative. Alright, last but not least, I can't have exponents. So I see I've got log base 7 of x squared. I would want to take this exponent of 2 and put it in front of the log. So I've got minus 2 times log base 7 of x for just that part. And then the rest of these, nothing has changed. Pause if you need to. When you have that down, flip over to the back. One more tricky thing that I want to show you, and that is sometimes they're going to throw you off by putting some square roots in there. Now the way that I can use a square root is by thinking of the square root power as a 1/2 power. Remember that the square root of x is really x to the 1/2. So what they have really given us here is log base 2 of x to the 1/2 on top, and then yz on bottom. At this point it's very, very similar to what we just did with example C actually. That means that the top is positive. That's positive right there. And then these two pieces on bottom are both going to be negatives. And remember, every single part gets its own log. Last but not least, we can't have exponents to have it be fully expand. So I'm going to take that 1/2 exponent and stick it in the front. And I'll be lazy this time and just move it instead of rewriting it. That is acceptable. Alright, let's look at E. And if you want to at this stage, you can pause it and try E and F. These ones are more difficult. But go ahead and pause it and try it if you want to, and then you can fast forward and check your work. What I want to think about for this part in E is that that square root is over the entire thing. And remember your properties from chapter 7? That means that I can split it up into the top and the bottom separate. And then also, because a square root is a 1/2 exponent, let's just immediately think of it like 10 to the 1/2 then divided by t to the 1/2. So I took the square root, I split it up, and then I changed the square root to a 1/2 exponent. And now you can see that I've got another quotient property going on. So I'm going to have log of 10 to the 1/2, and notice this is a common log, no base. So when I write my log each time, there's nothing there that I'm going to write. And then the part on bottom is negative. Last but not least, move your exponents to the front of each statement. So I've got 1/2 log 10 subtract 1/2 log t. Alright, I guess that wasn't that difficult. Let's try F. For this one, I see kind of just straightforward right away. It looks like I have the product property because I see that I got 64x squared is really 64 times x squared. I've got log base 8 of 64 then plus log base 8 of x squared. And I want to move my exponent, but also if you have a log that you know, go ahead and go for it. Here's what I mean. If I think, okay, what power of 8 gives me 64? I actually know the answer to that one. That one is 2. So actually find the log if it is something that you know. Alright, pause, make sure you got that down, write down questions. Let's look at example 4. And example 4 is basically the same thing, only we're going backwards. So now they're going to give it to you all written out. And our goal is to make it so that it's all together. So our goal is a single logarithm. And our goal is to have exponents. And I want to tell you that before, remember how I always moved the exponent to the front at the very end? This time we're going to do that first. So we're going to move the powers to start off with this time. Let's look at part A. Move your powers first. My first step then is to move this so it says log base 2 not log base 2, but log of 2 squared. And it is fine, actually, class. If there are things that you can actually multiply together or take the power of and that kind of thing, go for it. So I know that 2 squared actually is equal to 4, so I will say log of 4. All right, now let's use our properties. And when we're condensing, sometimes it helps students to think of doing it one at a time if needed. The same rules apply as what I said before, which are if it's positive, it goes on top. And if it's negative, it goes on bottom, based on that sign there. So let me show you the long way though, just to start off with, but then you can use that shortcut once you get the hang of it. So the long way is just do it one step at a time. So first I'll condense these two. So because it's a plus sign in between, I change it to multiply, and the logs drop, so I just have a single log. Now condense these. So now this will be on top, this will be on bottom because it's a subtract, so I got log 6 times, you know what, 6 times 4 is 24, so I'll say 24 on top and 3 on bottom. And then 24 divided by 3 is 8, so log 8 is my final answer there. Let's look at part B. Again, do your exponents first. This means I end up with log base 3 of 7 squared minus log base 3 of x to the 5th. Again, you can actually find the answer if you want to. This time I'm going to wait a second just to show you something here. This time I'm going this way and I have the quotient property again, so that means that 7 squared is going on top. X to the 5th is going on bottom. And remember, our goal is so that there's just a single log left and everything's with that single log. So I have achieved my goal if I just have log base 3 of 49 divided by x to the 5th. For part C, I want to show you what happens when I've got two different things on bottom. Check this out. So when I look at this, I'm going to first move my power again. So you know what? Let me be lazy again and we'll just kind of cross that out and make it an exponent. Okay? Now, remember how I said anything that was negative before was the bottom and anything that was positive was the top? So let's try to do this all in one step and see if this makes sense. So what I mean is x squared, 5, and y cubed are my three different pieces. Log base 8 is the log I'm using. So these three pieces, I got to figure out which one goes on top, which one goes on bottom. I know it's a fraction because I see subtracts. Alright, x squared is positive, so that goes on top. And the 5 is with the negative log, and the y cubed is with the negative log. So 5y cubed on bottom. I can definitely go through that again if needed tomorrow in class. Pause it, get it down, move on to part D. If I get a fraction that I can actually convert to a square root, you do want to actually do that. So for part D, I'm going to move this, but when I do a 1/2 exponent, I get log base 3 y to the 1/2, but a 1/2 exponent is the same thing as a square root. So let me say that again. So I had a 1/2 exponent there, but a 1/2 exponent is the same thing as a square root. So I've just converted it to square root of y there, and I just have a plus sign this time. So nothing too fancy is going on. If it's just a plus sign, use your product property. It's going to be 2 times square root of y when I combine my two pieces, and log base 3 is the log part of it. I'm going to keep going. I'm going to go a little faster at this point, so just make sure that you pause the video if you need to. Few things I want to show you for this one. First of all, I got a negative sign in front of a parentheses. We are going to distribute that just like a normal math problem. So this is going to be subtract for that one, and then a negative is going to be plus. I will move my exponents right away. So I end up with ln of 27 to the 1/3 power. I end up with ln of 3 squared. Notice the negatives are not moving with the exponents. The negatives are not moving with the exponents. ln of 16 to the 1/2 power. In this situation, all three of these are powers that I can actually do. So 3 squared is 9. 27 to the 1/3 power, try typing that into your calculator and you should get 3. And then 16 to the 1/2 power is like the square root of 16. Square root of 16 is 4. Now, notice that only this middle one has the negative log. And remember, ln log, same rules apply as log log. So, ln is my kind of log. These three numbers I just highlighted are the different pieces I have. I just told you 9 is going to go on bottom because that's the negative one. That means 3 and 4 are multiplied together on top. So I got ln of 12/9 or ln of 4/3 if I reduce it. Go ahead and pause the video and try part F. Alright, unpause, check your answer. If you need to pause it and look at what I did, feel free. I'm going to move on though because we're running out of time for this video. Change of base formula is next, and once I teach you this, you're going to wonder why I didn't tell you sooner, but we didn't tell you sooner because we always want you to try to do things as much in your head with mental math as possible. But I'm going to show you now. Let's say that I did get a statement like log base 3 is 6. That's one I can't do in my head because I don't know what power of 3 gives us 6. So we're going to use something called the change of base formula to type this into our calculator. Here's the formula. Let's say I had log base c of u. So c and u are just two real numbers. This changes into log of u divided by log of c. Log of u divided by log of c. And notice that what I've done right here is both of these are base 10. Both logs are log base 10, and the reason I wanted to do that is because log base 10 I can type into my calculator. You could actually change it to any base you wanted to, but you never see anybody doing other bases because the main reason we use this formula is so that I can type something into my calculator. So let's try this. So look at example A, and here's how I remember this. Let me tell you this. I remember the big number goes on top, the base goes on bottom. That's how I remember it. So if I was can't do that by my head, so I'm gonna use my calculator. Big number goes on top, little number goes on bottom. So I'm literally going to type into my calculator log base 6 divided by log base 3. Make sure you close parentheses if your calculator is one that adds a parentheses, and you should end up with 1.63. So go ahead and pause and try it in your calculator. So again, every single time big number goes on top, base goes on bottom. Type it in your calculator, see what you're getting. Go ahead and try C and D. And B if you didn't do so already. Go ahead and try C and B, and let's just make sure that you know how to do this correctly in your calculator. This is one part that students usually love because it's super easy. Ooh, log of -4 for D. Now notice this one already is base 10, so the only reason I changed the base is because it's not base 10. So this one already is base 10, so I don't have to do the change of base. But when I type this into my calculator, you get an error message. My question is, why? Why would I get an error message? We're going to talk about this more in class, but I'll show you quickly now. The reason I would get an error message is, this is the problem I'm trying to solve. What power of 10 gives us a -4? When I'm doing an exponent like this, and this base was positive, it's just not possible to turn it into a negative situation. Because if I use a negative exponent, it actually just turns this into a fraction. For example, this. If I use a fraction exponent, it just takes the square root. If I use a positive exponent, it just finds the number. So there's no way, no exponent I could find that would make it negative. So whenever I have something like this, it will be an error message. Now, one more quick. Look at log base -4 of 16. So this time I'm trying to do -4 squared equals 16. Now if you try this one is possible because x could be 2, but if you try it this way,